In this video, we are going to check about experiment number 6, which talks about regression techniques using Python libraries. Right? So now, first let us discuss what is regression, and then what is the need for regression, and then we'll move on to the coding part. So we know that machine learning, there are 3 types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. So in the supervised learning, we have the concept of regression. Right? So regression is nothing but we are going to predict certain variables, right? So in order to predict the variables, we need 2 components. Okay, so one is the feature component, right? So which will serve as an input. Okay, the second one is the target component, right? So we need 2 components. The first one is the feature component, which is the input, and the target component, which is the output. Now, let me first explain about the data set that we are going to do in this program, right? So here I am going to use diabetic data set. Okay, so let me show it in the coding part. So the diabetic data set, you have age, sex, BMI, BP, S1, S2, S3, S4, S5, S6. So these are all the features which can serve as an input in order to predict the target. So what is a target? The target is nothing but the diabetic progression indicator. That is maybe this person, the case 0. So what is his sugar level after a month? Okay, similarly, this is case 1. What is his sugar level after a month? So now what is that we are going to predict is if the age is this, the BMI is this, the BP is this, the S1, S2, S3, S4, S5, S6 indicators are this way. So what will be the target diabetic? Okay, is what we are going to predict it. So how are we going to go about with this prediction is, so for any regression problem or for any machine learning problem, we'll have training set, especially for the supervised case, we'll have the testing set. So first we have to split the data set into training set and the testing set. So usually 70 to 30 proportion or 80 to 20 proportion is used. Okay, so 70% for the training and 30% is for the testing purpose. So the entire data set, so you say I have the inputs and I have the targets. This is what we are going to predict. The target is what we are going to predict it. So if we have this, I'll just split it into 70-30. Okay. So this 70%, I'll give it to the algorithm and I'll train the algorithm. So if this is the age, this is the BMI, this is the BP, then this is going to be your sugar level. So that is what I'll be just predicting it. Okay. So 70%, I'm going to test it. Then I'll be using the remaining 30%. Okay. So usually we'll call this as X train, right? And we'll call this as Y train. And we'll call this as X test. And we'll call this as Y test. So Y test is the actual value. Okay, Y test is the actual value. So now what will I do is initially I'll train. That's the first phase is you are going to split the data set. The second phase is you are going to train the algorithm. And the third phase is you have to test it. So when you are testing it, you will be testing with X test. Okay, you will be testing with X test. And you will get a value called Y predict, right? So you will get a value called Y predict. So you will test it with the X test and you are getting something called Y predict. Now, you will compare this Y predict with that of Y actual. Okay, that is a Y test. Okay, you will compare it and then you will say that the algorithm is 90% accurate. Okay, so you will measure error level. Usually in prediction, you will go for measuring error. Okay, so root mean square error, root square error, and you will go for measuring the error. Okay, so suppose my Y test is 30 and my predicted is 28. So I'll say 30 minus 28. Okay, so based on this, I'll decide what is my accuracy level. So here again, we'll now check out what are the functions used for this prediction using the Python code. Let us go to the coding part. So We are going to import the data sets, import the libraries, import pandas and numpy. So in this experiment, we are going to use the sklearn libraries. First is for the model selection, for splitting your training and testing. I told you have to split, train and test. So this is what the first library we are importing. And the second library is used for linear regression. So initially we'll do linear regression. So what is linear regression? Suppose I'm taking one feature. Okay, I'm taking only the BMI. I'm taking BMI. Okay, so only using BMI, I'm going to predict what is the target, what is the sugar level. So this is called simple linear regression. So what the condition is, there should be a linear relationship between the X and the Y. So say this is BMI and this is my sugar level. There should be a linear regression. Linear regression means whenever the BMI increases, the sugar also should increase. So this is called the level. Okay, so there should be a linear relationship. Okay, so the relationship will be something around here. Okay, so this is how the points are plotted. Okay, so this is simple. So what is multiple linear? So I'm going to take some more features, BP, S1, S2, S3. So I'm going to take multiple features is called the uh, multiple linear regression. This is the second regression technique that we are going to experiment and check it out. And the third one is called the polynomial. So why do we have to go for polynomial is most of the time when the points are like this, it does not fit the straight line. It does not fit the straight line. In that case, a polynomial curve will try to fit the lines so that you get the proper prediction. Okay, so in that case, you will go for polynomial regression. And from the polynomial regression, we are going to move on to lasso and ridge regression, where this lasso and ridge regressions are regularization algorithms. They are not actually the full prediction algorithms. They regularize and then they go for a prediction. So what is the regularization? So if you see sometimes the prediction line, okay, the prediction line, so you say these are the points, it exactly fits all the points, okay, or I go for polynomial regression. So it exactly goes through all the points, which is sometimes called overfitting, okay. It's sometimes called overfitting. Say I have 30 as y test, my prediction is also 30. 40 as y test, my prediction is also 40. So this may not work out for some data sets. So in that case, I'll go for lasso and ridge regression, where those both regression techniques will regularize your parameters so that there is not a overfitting. Your algorithm does not learn too much so that it sends even a wrong value as a right value, right? So that is what we will be experimenting here. So we'll go to the coding part. So the first portion is you are going to import the libraries, then train test. Then initially we'll go about with linear regression, then the metrics. So here mean square error and R square score are measured in order to find the difference between the actual value and the predicted value. Then for our experiment, we are going to load the diabetic data set. So you can even use pd.read underscore CSV and load it. Okay. And all the input variables, you will call it as the X. Okay, so I say X is equal to df of, okay, so I wish to have only the BMI now because this is simple linear regression. So X is equal to df of BMI. Okay. Then maybe I have Y equal to df of target. Okay. So target is the single one. So let's say target. So now I have decided what will be my X variable and what will be my Y variable. So after that, we have to uh, split the train and the test. So I just say X train, comma, X test, comma, Y train, comma, Y test. So Y underscore test, right? So Y underscore train, Y underscore test, okay, is equal to the function train underscore test underscore split of X comma Y comma test underscore size equal to 0.2, which means that 20% I'm going to take it for the test and 80% I'm going to give it for the uh, train. So now, and the random state 42, I'm introducing a little bit of randomization inside the selection of the test and the train variables. So yes, it was done. So we'll move on to the next cell where we are going to write the model. So the model, I'm going to select the linear regression, right? So I say linear regression, then say model dot fit. I'm going to train it based on the model. Okay, model dot fit of x underscore train, comma, y underscore train, right? So I say that using this training data set, that is 80% of the data, I'm going to train the model, right? So after we just train the model, we are going to predict it by underscore predict equal to model dot predict. So for prediction, we have to give the test. Okay, x underscore test, right? So we have predicted it. And then we have to evaluate the model. Okay, so evaluation is very important. Whether my prediction value is good, I have to evaluate it. So in order to evaluate the model, I'm using certain functions. That is, initially I'm going to calculate the model coefficient and the model intercept. So your equation will be y equal to mx plus c. So you need to know what is the m and what is c. That is what is calculated here in the model coefficients and intercepts. And here is where we are going to calculate the root mean square error, then the R square score. Okay, so based on this, it gives me 63, value 63 as the root mean square error, and R square score is 0.23. Now we'll move on to the same using multiple regression. Okay, so we'll say, how about the multiple features? When I take multiple features, how it is done. So in the multiple regression, I'm taking the x variable, I'm dropping the target so that except the target, all the variables starting from age, BMI, BP, S1, S2, till S6 serves as the input. And Y is the target. So we have to split the train and the test. Then linear regression, okay, call the model function. Then in the model function, you fit the training data, then you predict it. So after you predict it, we are going to calculate the mean square error and R square score. So you understand that the error has come down when we are considering different multiple features. But instead of taking 2 features, I've taken all 6 features. In that case, my error has come a little bit down. Okay. And these are the model coefficients. So earlier I told you in a simple linear regression, you will have y equal to mx plus c. So that's why the coefficient and the intercept is calculated. Here, we'll have many coefficients. Say B0, B1, B2. In that case, so the model intercept B0 is calculated and B1, B2 is calculated this way. Similarly, for the polynomial regression, so we are taking the import polynomial features. Okay, so we are going to introduce the concept of pipelining also. So for simplicity, okay, for to make the not to make it too complex, we are having only one variable. We are taking only one variable, then we are splitting it. Then we say the degree of the polynomial is 2. Okay, so we are going to have a degree of polynomial 2, not more than that. Then we are introducing the polynomial features. Okay, and then we have the regression, calling the regression. Then we fit it into it, and then we predict it. Then the calculation of the scores. So when we compare the polynomial regression and simple regression, we understood that the error has not improved. Okay, the error is same. Maybe because we took BMI for both the cases, took BMI, so it is. But so we have to take more correlated feature. Okay, we have to find in statistical inference, we discussed about the correlation technique. So you have to find out which feature will be the best feature for finding out the regression. Okay, for finding out the regression, and then we have to do it. Okay, so if we do it in that way, then the error can come down. Similarly, we'll also do lasso regression. So the syntax for doing the lasso regression is so again, the step follows. It is you split the X and the Y. Okay. Then you have the feature names and you have the split test and train. Okay. So then for the ridge regression, the function is ridge. Okay. So you can even try out with different alpha value. And for the lasso, it is LASSO. Okay. So the model dot fit X train Y train. So you are training the model. So after you train the model, you will test the model. Okay, so you'll test the model, and once if the test is done, you'll compare the models. Okay, and after comparing the model, you understood that the values of the lasso regressions are this way. Okay, so R square for linear is 0.45, 41, and 47. And similarly, you can even do it for the squared error.